Okay, we're going to start working on the homework here. 625. As Sally and George practice for the SAT, their scores on practice tests rise, because that's what happens when you study. Sally's current score is 850. That means what she's getting right now, and it is rising by 10 points per week. On the other hand, George's current score is 570 and is growing by 50 points per week. The question is, when will George's score catch up to Sally's? So let's think about this. We're going to start at 0 weeks. But then we'll just do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops. 10, 11, 12. It's up to 13 weeks. Cool. Okay. Sally's score. Sally's current score is 850. That would be her B or her y-intercept because that's what she starts with. So that's 850. And it's going by 10 points per week, so that'll be 860, and you know the rest, 870, 880, 890, 900, 910, 920, 930, 940, 950, 960, 970, 980. That's Sally's score, and then we're going to do George's score. George's current score is 570, but is growing by 50. So 570 would be his start value, and 50 would be his slope or growth value. So we're going to start at 570, but we're going to add 50 every time. So George, that would be 620, just kidding, haha. 670, 720, 770, 820, 870, 920. Notice the pattern here, 970, 1020, 1070, 1120, 1170, and 1220. Okay, so let's see. When will George's score catch up to Sally's? So let's see, when can we compare them? It looks like this is the time when you see 920 and 920. It'd be better to not be on the page break, but you can still see it. 920, 920, that would be after 7 weeks. So George is coming from way behind to pass her up. All right. Next, if the SAT is in 12 weeks, who will have a higher score? So 12 weeks. Sally's got 970. George has got 1170. George will have 1170. Sally will have 970. George gets the higher score because he's studying really hard and he's doing great. Cool. Go George. All right. 626. Solve for x. Check your solutions if possible. Graph your solutions on a number line. Okay. We'll definitely check them by plugging in. So we're going to solve for x. So the first thing we got to do is distribute this -2. And oops, -2, which gives us -2 times 4, which is -8. -2 times -3x is +6x. And then it's going to say -6x because that's what's left. And that's going to equal 10. And what you notice is that you have +6x and -6x, so we're going to combine like terms. Because those x's are like terms. And what happens is that the positive 6x and the negative 6x cancels out, and we get the awesome equation -8 equals 10. And you're like, no, it doesn't, and you're right. This is never true. So we get to say no solution. ... All right, done. Okay, B is a little tricky, but let's give it some respect. Basically, x over 5 divided by 2 is equal to x over 1 divided by -3. And the first thing we want to do is get rid of that 2 on the bottom because we're trying to get the x's alone. So what we'll do is we'll multiply both sides by 2. Okay, multiply to both sides. And what that gets us is, well, the 2 will cancel out there, so you'll just have x minus 5. Because the 2 in the denominator cancels out. And that will be equal to, and then we have 2 times what we had before, which was x minus 1, all of that divided by negative 3. All right, now we're going to have to distribute that 2. So we're going to distribute 2. And what that's going to get us is x minus 2 equals, we distribute the 2, so 2 times x is 2x. The 2 times the negative 1 there is minus 2. And all of that went into the parentheses because we're still dividing this mess by negative 3. All right. Now, like what we said before, we want to get rid of the denominators to get x alone. So what we're going to do now is multiply by negative 3 on both sides to get rid of this denominator. So we do that. That's not how you spell multiply. I know that's how you spell multiply. Multiply. Negative 3, comma, both sides. And what we get here is that x minus 2 equals, let's see, now we're multiplying by negative 3, so we got to do negative 3 times x minus 2. And just to be sure, what I'm doing is multiplying by the negative 3 to get rid of it there, but I have to do it on this side. So now it's there, and that will be equal to parentheses 2x minus 2. Now I've got to distribute this negative 3. And what that will get us is negative 3 times x is negative 3x. Negative 3 times minus 2 is plus 6. And that will be equal to 2x minus 2. All right, we're getting closer. We still need to get x alone. So what I'm going to do is I'm going to add 3x to both sides. We're getting close. Be patient. Add 3x on both sides. And what that will get us is 6 equals 2x plus 3x is 5x minus 2. Yep, we're good so far. So now I'm going to add 2 to both sides. And what that will get us is 8 equals 5x. So to get x alone, last thing we'll do is divide by 5 on both sides. And that will get us x equals 8 divided by 5, which is a perfectly good answer. There you go. B is done. Okay, last. On the same set of axes, graph each line in the system shown below. What is the point of intersection? Or does more than one exist? How do you know for sure? So we can just graph them. And when we do, we'll find that y equals negative x plus 2 and y equals 3x plus 6. They either graph in multiple places or one place. So y equals negative x plus 2. Let's give that a shot and deselect all this other madness. Y equals negative x plus 2, okay? Pardon me. And the other one is y equals 3x plus 6. And so we can see that the two of them, they cross right there at negative 1, comma 3. So what is their point of intersection? Very simply, negative 1, comma 3. Does more than one exist? Do they cross in more than one place? No. Lines, straight lines, they can only cross in one place. If they're the same line, then they will cross in every place. But two different lines can only cross in one place. So Does more than one exist? No. Only one point of intersection EXISTS. That is true. How do you know for sure? We don't need that E tool. All we need to know is that the graph demonstrates that there is one point of intersection. Demonstrates. Sounds like a great philosopher. One int. Let's go with point. Totally way more convincing that way. Okay. Looks like we're done. Cool. We're done.